Good morning, everyone. This is Carl Griffith from Graybar, and I'd like to welcome you to our monthly G2 Talk webinar. Today is a discussion about transforming our infrastructure into a utility-grade network, and that's our goal. What is that migration path that we need to get a utility-grade infrastructure to support the networks that we need for the future? Before we get started, I'd like to give you a few items that help us through the 30 or 35 minutes that we're with together. First of all, the first 50 people that are online and join the webinar and stay with us will get a certificate in their email for a cup of coffee from a large major coffee company. So look at your email. You can take that email to that local chain and get yourself a cup of coffee on us. Second of all, we will have Q&A. So there's an opportunity for you to ask questions at the webinar. If you look at the bottom of your screen, you'll see a little Q&A button. If you hit that, a dialog box will open up. If you'll type your question in that dialog box and transmit it our way, when we get to the Q&A portion of the webinar, we'll address as many of those questions as we can. If we don't get to those questions, we will definitely respond to you via email and answer your questions. The entire webinar will be archived on graybar.com. So if you go to graybar.com and click on the G2 Talk logo, you'll see an archive button there. You can go there and you can get this presentation again. Look at it again if you want, or share it with your friends and neighbors. That'd be great. Also up there at that link will be a white paper to discuss the topic that we have today. And this presentation in a PDF format will be up there. So you can actually see it again. You can share that information again and refer to it. Our presenters today are, or before we get started with our webinar, I'd like to talk just a little bit about Graybar. Graybar is a distributor of communications and connectivity and electrical products, and our mission here is to help our customers power, network, and secure their facilities, in this case, their data center and their networks, with speed, intelligence, and efficiency. And we're spot on with that mission today with our presentation. We're going to talk about reduction of power. We're going to talk about networks and security. We're going to spend some time talking about bandwidth, intelligence, and efficiency, and those are all themes that will be on our discussion today. Our presenters today are two friends of mine, and this is just an absolute fun time to be together. Our first presenter is going to be Dave Cunningham. Dave Cunningham is the Director of Business Development for Tellabs. Dave has a tremendous amount of experience in the industry. He's come out of the industry from a physical layer connectivity perspective in terms of optical networks. But prior to that, he's also worked in IT, and he has a lot of experience with an IT background designing and implementing networks, both LANs and WANs, and he brings an extreme amount of information to us about networks. He's the Director of Business Development for Tellabs, and Dave's a graduate of Bob Jones University. Our second presenter will be Ray Barnes. Ray's the Manager of LAN Market Development for Corning. He's been with Corning for quite some time. Ray's been involved in some very large optical cable projects around the country with Charter Communications, for example. He's worked on some pipeline projects. He's worked on some leaf fiber deployment for the United States Army, etc. He's been involved with advanced optical networks at Corning and helped design some of the products that are in the Corning catalog that you see every day today. Ray's has a double E from North Carolina State University. So we're just extremely grateful to have these folks with us as we talk about advanced networks and advanced infrastructure. One more point of order before we get going. Both Dave and Ray participate in an association called the Association for Passive Optical LAN, or sometimes known as APOLAN. Dave's the president of APOLAN. Ray's the secretary of the marketing committee for APOLAN. Both Tellabs and Corning as companies are members of APOLAN. Graybar as well is part of APOLAN. If you're going to be at Bixie next week, APOLAN will have an exhibit there. You're welcome to come by and visit with us. They will be at booth 1331. If you want to come and see me, I'll be standing in the booth on Wednesday, as Graybar is an APOLAN member as well. So without any further delay, I think it's time for us to get moving with our presentation. So I'm going to pass the baton off to our friend Dave Cunningham, and he's going to talk to us a little bit about LAN challenges as we move forward with the discussion about building that utility-grade infrastructure to support our networks of the future. Dave, thank you for joining us today.
Well, thank you, Carl. I appreciate the great introduction, and I'd like to welcome everybody on the webinar. I appreciate your taking time out of your day to attend this. I wanted to talk a little bit about today and kick off the discussion with a kind of a conversation about how the LAN has changed in the current local area network requirements that we have. And we really can't start that discussion without talking about where the LAN came from and how the local area network has evolved over time. So back when I was in IT and building and deploying local area networks and responsible for the architecture for about 80 facilities globally of the local and wide area networks, back at that time, there was a lot of local LAN traffic, and according to Gartner back then, 80% of the LAN traffic stayed local. That's because you had small departmental servers. You know, the human resources group had a little server under somebody's desk using Novell NetWare, which was really innovative at the time, a way to share file storage and secure documents and allow access to shared files and those kind of things. And that was really kind of what perpetuated the connectivity of a local area network inside a building, was to get access to those files, either the engineering folks sharing files on a local server or something of that nature. And that access was generally not time critical. It wasn't business dependent. If I couldn't access the server, before I went to lunch, I'll go to lunch and maybe it'll be working when I get back, and everything will be fine. And what we've seen is that connectivity has grown over time in importance and in the number of things that we're connecting to and that are connecting actually to the local area network. Now, the Gartner study recently in 2014 showed that 90% of the local area network generated traffic flows directly off the local area network and out to the wide area network or the internet, right? And what that means is that the traffic patterns are really kind of changing, and that migration of data that's getting farther and farther away from the user that no longer sits inside the building, that access has become more critical. The fact that now we're accessing internet-based applications like Salesforce.com, some cloud-based ERP systems, those kind of things. The managed services, the appliances that allow internet access in and out of the cloud that are actually hosted out of the internet cloud. We have voice and video are two early on applications that were added to the local area network that really changed how we looked at building a local area network. And now this next wave of convergence, building automation, lighting systems, security systems, all these devices that are connected to the local area network that have to be available and always on. Add to that the wireless traffic that's exploding in popularity with mobility and Wi-Fi traffic inside the office, cellular connectivity inside the office, that always-on connectivity that we talk about, and even the employee's personal connectivity to the outside world. It used to be you'd pick up the phone to call and make sure the kids got home from school. Now that's a text message that you expect to get, and so having that connectivity inside the office is really important. And all that stuff that we've added to the local area network now has generated some security concerns, because once those devices are on a network, they have to be able to be managed and controlled, and only allowing the people that need to access them to be able to have that access. And then that last bullet point, that LAN access over time, it's kind of like watching your kids grow up, right? They're young, and then all of a sudden you turn around and look, and they're in college. And I'm going through that now, with my kids, and you wonder where the time went. And I think that's the same thing with the local area network. It has grown up. It has become a time-critical and a pervasive application, a utility-type connectivity that we expect to have all the time. And while all those things have happened and the local area network requirements have changed, what really hasn't changed a lot is how we design and build those local area networks. The traditional core distribution access design that's been really popular for quite a long time, it really has grown up out of the demand for reliability, the demand for more access. And the challenges with that are where Ethernet was designed to really simply connect a device to a hub and give it access to other devices in a relatively best effort fashion. Now we've had these complicated mesh networks that we have to build with dual core switches and redundant connectivity all the way through the access layer, and all that complexity really has given us a local area network that we really can't control. It's very expensive to build. The network closets that used to be relatively simple are now very complex. They're very large. They require a lot of power. They require a lot of cooling. And all that stuff in the middle of the network has to be managed in some fashion. And it's really created a lot of challenges because since we really can't manage the traffic that's flowing through the network, really a lot of times the only solution to a problem is to throw some bandwidth at it. And all that complexity that we've added with the meshing and all the different protocols and things to allow that mesh-type network to happen can actually contribute to the downtime we're trying to avoid by building these complex networks. You misconfigure a single port on a single switch, and all of a sudden, nobody can access the local area network, and we spend time troubleshooting and tracing those things down, and it really makes it hard to troubleshoot because we don't know really how traffic is flowing through that network. And the lack of a true centralized control management system, it can add to the frustration because you build a management system to try to manage these devices and then realize that you really can't effectively manage the herd of cats that we're trying to control. So really, the problems that we have with the complexity of that network are compounded by the fact that we always expect the network to work, right? There is no unnoticed downtime anymore. Used to be you could work on the local area network in the evening and nobody would notice because nobody's using it. Now you can't do that because the security systems that are managing the access to your facility rely on that local area network, and you can't tell the security guard up front that for an hour he's not going to know who's entering and leaving the building. So that constant always-on requirement, really the latency of the network has become very important because of the voice and video traffic that we have to flow over it, right? And a lot of people talk about voice and video driving bandwidth when actually really what the problem is voice and video traffic requires low latency because they don't take a lot of bandwidth compared to a lot of other things. A voice call can be as small as 8K and as large as 128K, and that's not meg, that's kilobits per second. And that really, in the grand scheme of a local area network with 100 meg or a gigabit port connecting you to that switch, 128K is relatively easy to handle. But what it's hard to do is guarantee the latency and make sure that there's no other impedance to traffic along that path. And again, that's just a compounding factor that we have that is generated by these complex local area networks that we've built. In fact, I ran across an article last month that really kind of highlighted this for me. It's in a Network World magazine article. If you Google "Our Bulletproof LAN Failed," you'll see an article by Paul Wimpenny, who works for the United Nations, and basically describes a network failure that they had in their what they thought was bulletproof LAN. And his greatest concern was the LAN that they had, this bulletproof LAN that they built, was so complex that it took them 4 hours to recover when they had a failure. And he listed some risks there. I'm not going to go through those in detail, but really the point is, his point of the article was, the greater the complexity of the network, a lot of times if you have a failure, it makes it a lot harder to recover, and it puts you at risk for having the downtime. And one of my key points today, if you don't take anything else away from this, is that these are not just IT problems with the local area network. The local area network is now a business critical function, and when there's downtime or issues with the network that cause problems for the end user, those are now business problems. So when I can't run a report on the ERP system because of slow connectivity or no connectivity to a given server or remote resource, that's a business problem. That's not merely an IT problem anymore. And when my phone call drops or I get a busy signal because the network is too busy for my voice over IP call to happen, that's a business problem. It actually impedes the business, and they don't go unnoticed. And so really, what's the path forward? How do we fix that, right? So we understand we've got a problem. The networks are complex. If you look at the lower left-hand corner of the screen there, you'll kind of see the mesh of switches that needs to be created to build a local area network and build it reliably. And actually, you could put some more cross connections in there and more connections from the core switch out to the other switches. And the challenge is we really don't know how that traffic flows through that network. It really still is a best effort medium. And that the passive optical LAN that we're going to talk about today is different in that it doesn't have that complex middle of the network. A passive optical LAN is passive in the middle of the network. That's obviously where it gets its name from, and uses the optical network for that distribution, which alleviates all the huge mesh of electronic components that we have to have in the middle of the network that each have to be managed individually. That give us configuration challenges because they have to be configured individually. You have fewer electro-optical conversions, electrical conversions. So you've got better utilization of the latency burdening devices. Don't have to go through all those conversions and have a smoother path, shall I say, to the core of the network. And then the passive middle of the infrastructure, and this is huge, it eliminates the need to build the IDFs, these life support mechanisms that we have for the middle of the network in a traditional Ethernet network. If you look at the changes in the rooms, the network closets from 15 years ago, the amount of power and other devices we put in there, the cooling, all those things, they all have gotten a lot more complex and, again, can introduce security challenges because now I have to secure that room. I have active gear that can be tampered with. I have to know who's going in and who's going out. Just adds a lot of complexity to the infrastructure. And what that all means is that, the passive optical LAN solution being passive in the middle of the network and giving you control over the network really allows you to centrally manage and understand what's going on in your local area network. Tellabs is the world leader in passive optical LAN. We've been in this business for a number of years. The start was the demand in the federal government for secure networks in a way that they couldn't achieve with a traditional Ethernet network. So we've been deployed in the most secure Department of Defense and Homeland Security networks and some of the networks that have super secret information that needs to run over them. Our Panorama management platform allows you to centrally manage any passive optical LAN infrastructure in your company. So if you've got 80 facilities around the world, you can have one management platform from which all those configuration changes happen, and you can see what's going on in your network, understand it, and because we've reduced the number of elements that you have in the network, really understand and know the traffic flows and make sure that you've got a reliable network in place at each of those facilities. We have software extensions that we've added that allow you to enhance your security or your operational efficiency and availability, and that allows you to custom design a solution to fit your particular environment. And then obviously the hardware software features that allow you to have a reliable, robust infrastructure. And as Carl said, we participate in the most influential organizations. That would include the Association for Passive Optical LAN, TIA, other industry associations for specific verticals that really influence how networks get deployed and highlight the importance of an all-optical infrastructure. So I'm going to pass it over to Ray and let him tell you more about the optical infrastructure of a passive optical LAN. Ray is a good friend from Corning, and Ray, I'll let you take it away. Thank you.
Hey, thank you, Dave. And I'd just like to take a second to thank everyone who's on the call for taking time away from their day as well to listen to my portion of the talk. So essentially, what I want to kind of start out with is and Dave touched on a few of these points, but it's kind of like what's going on with the network today. There's a lot of trends and challenges that are affecting the local area network today. If you look out there, some of those trends are cloud services. Of course, more and more things are being taken off of the local area network and being done in the internet and the cloud. And so that puts more demand on your wireless area, or your wide area network, but not necessarily your local area network. So, there's increasing complexity in the network as more and more devices are being connected to the network. More and more applications are being converged onto the network. The network is essentially becoming more complex and, basically more critical to getting the work done, essentially. And then, of course, virtualization is another thing. Of course, we talked about convergence and the need to basically maximize the benefit of your infrastructure by converging multiple disparate networks onto one network. And then, of course, if you look at from a people point of view, there's increased mobility. Everyone brings their smartphone to work, their tablet, their laptop computer. There's lots of devices that demand mobile connectivity, and, of course, that could be in wireless or cellular. And then basically this whole idea of extended collaboration where you can take your device anywhere in the building and be connected to the folks that you need to work with, really anywhere in the building, anywhere in the network. And then, of course, social networking kind of is one of the trends as well. In the old days, you might have a lot of business cards and a Rolodex to keep up with your contacts. Today, you may do that on LinkedIn or some other social networking site. And basically, those are some of the trends. Now, those lead to challenges in the network as well. So essentially, with all those connected devices, you have a lot of increased mobile devices and the complexity that goes along with that. In a lot of cases, as these networks evolve, it demands an IT strategy to basically not only compensate for where the network is today, but also make sure that that network is available and essentially ready for the future as well. And then in some cases, this could lead to infrastructure upgrades. And from Corning's perspective, what we are trying to get into our customers' mindset is that, with the next infrastructure upgrade that you do, why not upgrade to an infrastructure that you're not going to have to touch for 10, 15, 20 years into the future? A network that's going to be scalable and flexible and really stand the test of time, essentially. And I'll talk a little bit about that later. So essentially, if you look at the network challenges, you have a lot of wireless LAN connections, security concerns, interference issues with all the wireless devices that you would have in your network. And you want to make sure that you accommodate for flexibility and scalability in your local area network. So these are some of the things that are really causing increase in demand for cable and, of course, connectivity in the local area network. So on to the next slide. If there's really three things that Corning looks at as far as where we think a network should be designed to, it's really simplified infrastructure that really makes move adds and changes easy for the end user. So basically this means that you have an infrastructure that should you need to add another device, add another connection, it's very easy. The network is going to be available. And then, of course, high capacity, so lots of different wireless devices, lots of different connected devices on the network. And then if you look at it from a converged infrastructure, this is really where the efficiency comes in. So it's really being able to use one network to do all sorts of things within your building, essentially. And this really just means that you're converging networks that used to be disparate networks onto one IP network. And that's essentially what a passive optical LAN does. It provides an IP infrastructure that you can connect all kinds of devices, whether they be standard PoE or PoE plus devices, into that network. And then the third point is, you really need an infrastructure that's advanced. And by that we mean an infrastructure that's going to stand the test of time, that's going to be able to go through multiple expansions, and it's going to be sustainable over time. It's going to be able to accommodate not only what you're doing today and what you can foresee, but also the things you can't even foresee into the future. So that's really kind of where we're looking ahead and trying to provide our customers with a network that's really going to stand the test of time. So so now we're going to kind of look at what POL is, and essentially where the all-optical backbone that a POL provides, what does it do for the local area network? So of course it's going to support all the LAN functions, Wi-Fi connectivity with wireless access points, as well as distributed antenna systems. So certain customers are starting to deploy these indoor DAS systems simply because they're not getting good cellular coverage indoors. And so an all-optical backbone can even support the DAS system inside of a building. And then, of course, building automation systems are becoming more and more common. So, for things like access control, even telemetry and asset tracking within buildings, we're seeing a lot of those systems being put onto the IP infrastructure. Of course, the LAN should have the capacity to upgrade. And then, of course, with fiber, you can actually reduce the footprint of the network altogether and make it more adaptable to the building, more adaptable to the situation that you're in. And then, of course, ease of installation and maintenance is always something that we're very concerned about with Corning, and we want it to deliver a network that's easy to install as well as maintain over time. And then, of course, we want to make it flexible so that you can incorporate future technologies. So those are some of the points that Corning believes we should be incorporating into our networks going forward. So the next slide is really where I want to start introducing this term of a utility-grade network. So where did this come about? So essentially, when you start looking at single-mode fiber in a network, and this is really what the basis of a passive optical LAN, it's a single-mode backbone that's essentially serving all the way out to the end user in some cases. So what this does for you, if you look at copper over time, we went through many different generations of copper. So from Category 3 all the way up to, I think the standards are working on Category 8 now. So lots of different generations of copper there. Even on the multi-mode fiber side as the medium, we've seen different generations of multi-mode fiber, starting with OM1 at 62.5 microns, going to a 50 micron core with OM2, and then essentially now we're at OM4 fiber. So essentially we've seen these medium essentially improve the performance over time to meet the demands of the network. But with single mode, if you look back for the past 20 to 25 years, when we invented SMS fiber, essentially it has remained the same. The performance has been improved with respect to attenuation. We have lower all single mode fiber, and today the single mode fibers can actually, they're very bendable, so they're bend insensitive. So you can literally wrap a single mode fiber around a pencil multiple times, and you don't attenuate the light signal that's on that fiber. So essentially, single mode has been very stable over time. So we kind of view that as being like the piping in a building, or if you apply it to a building, like the pipes in a building, or the wiring, the electrical wiring in a building. Whenever you want to upgrade a single mode fiber system, you simply change out the devices at the end of the system, and that's where the concept of a utility grade infrastructure comes in. Because single mode fiber has a virtually unlimited bandwidth, I believe it's in the multiple terabytes now. Basically, the end devices determine the bandwidth of that media. So there's really a direct upgrade path. So there's no more rip and replace with single mode fiber. When you want to upgrade to the next speed, you simply change out the endpoints, and that's really where that utility grade comes from. So another great thing that can be leveraged with respect to passive optical LAN is a composite cable that provides Class 2 power out to the edge of the network to a telecommunication enclosure, also known as a zone box. So what that helps us to do is eliminate the AC plug at the ONT. So by remote powering the ONT, we can essentially move all that battery backup that might be necessary for the ONTs and the distributed electronics, move that back and centralize it at a closet. And then, of course, ONTs can also be powered directly in a TE, and then they can be connected to edge devices such as wireless access points, security cameras, etc., by PoE or PoE+. And then, of course, that doesn't mean that you can't mix and match. With these systems, they're very flexible, very versatile. So you could have some ONTs in telecommunication enclosures that are powered remotely, and then you can have other ONTs that are simply patched through the zone box or telecommunication enclosure and powered locally at the desk. So in some cases, it does add a little bit of cost to remotely power an ONT. So in those situations where you want to maximize the economy of the installation, you may want to locate some ONTs locally at the desk and power them locally, and then remote power some as well. All right, so the next slide is kind of getting into the, why would you deploy passive optical LAN from a value prop perspective? And anyone who's been around fiber for a while, this first bullet here, pathways and spaces, you probably already know the benefits of fiber in those pathways and spaces. If you look at what a Passive Optical LAN does, it takes a 3mm fiber cable, and that fiber cable will actually feed an ONT with 4 ports on it. So you're essentially replacing 4 category cables in the horizontal space. So what that means is there's less weight, less bulk of cable, and the cables can often be supported on J-hooks instead of cable trays. And then, of course, because you're removing layer 2 switching from closets with Passive Optical LAN, you're also removing that telecommunication closet infrastructure. So there's no power infrastructure needed in the case of a pure POL install, no cooling infrastructure required, and then the space that you save in those TCs by either consolidating or making the TC smaller can be used for other things. And then the lower operating cost here really comes from the power savings of the Passive Optical LAN electronics. They're much more efficient than Ethernet, standard Ethernet switches that are distributed in the closet. And then on top of that, there's reduced cooling load associated with removing those switches from the closets themselves. So if we look, kind of switching gears a little bit, look at where we are with POL deployments in the marketplace. There's a lot of installations that have happened out there, and they're kind of arranged in multiple different verticals. So as Dave mentioned, the U.S. government really loves to use Passive Optical LAN for a couple of reasons. First of all, it's of course very cost effective, but they operate a lot of campuses where you have multiple buildings being served by the Passive Optical LAN, and then on top of that, they like the security that they get with Passive Optical LAN. It's an optical signal, so it's already difficult to tap covertly. So in other words, if you try to tap an optical fiber, you bend it, some light leaks out, but you can essentially monitor that link and tell if someone's tapping into it. So the government likes that fact, as opposed to a copper cable where you simply need to put some sort of an element next to the copper cable, and then you can essentially tap the signal of that copper cable. So in addition to that, POL is inherently secure because it's encrypted at 128-bit AES encryption. So that's one of the reasons that we've seen a lot of deployment in the U.S. government. And I should point out that this list is definitely not an exhaustive list. These are just some of the deployments that we've seen in these verticals. Another big vertical is the education vertical. And here we have several different universities that have deployed Passive Optical LAN. In the university, Passive Optical LAN feels a great need. Again, it's a campus environment, multiple buildings being connected. A lot of times you'll have areas where there's dense needs for connectivity, such as in a classroom, or you could have a multi-dwelling unit, a dormitory, or student living areas. And essentially, that's a very good fit for POL since it got its start in fiber to the home. That's just another type of MDU application or multi-dwelling unit application. So the POL system fits very well into that. Then, of course, lots of interest in the commercial space, lots of deployment, and then healthcare and hospitality as well. So healthcare and hospitality is an area where POL is starting to take off fairly well. Marriott just recently adopted POL as their standard network infrastructure going forward. And from a cost perspective, it's very, very efficient at getting the bandwidth needed to each individual room. And then in healthcare, the reason that POL is so well accepted is that once you install the infrastructure, you really don't have to go back and augment that infrastructure in the future. And that's important in a hospital, especially when the infrastructure exists in the drop ceiling environment, because there are regulations that limit your access into that drop ceiling once the cable's installed. They actually have to use special tents and tent off those anytime you open up a ceiling panel to basically keep any contaminants or anything that could potentially cause an infection from coming down into the hospital environment. So with the single mode infrastructure, once you install it, you essentially can leave it there and you only access the endpoints in order to upgrade the network. All right, so Corning's approach to Passive Optical LAN, we basically invented the original LAN hardware, the CCH housing or closet connector housing, about 20 years ago. And then since then, about 3 years ago, we actually initiated a pretty extensive voice of customer effort. We went out and interviewed about 200 customers to improve that product. So we have a very robust LAN product, and since Passive Optical LAN is just an extension of the LAN, we basically use our same LAN hardware to serve the Passive Optical LAN needs. The CCH is very flexible. It's available in a 1U to a 4U, very modular. Anything with a landscape panel footprint will fit into this housing, including things like splice cassettes, preterm modules, copper panels, we even have a power distribution unit, as well as you can get the edge footprint modules to fit into this as well. So this is what we've chosen as our flagship to deliver Passive Optical LAN. And really what enables us to do this is our ability to incorporate our Generation 3 splitter into the CCH housing. So that's the splitter you see on the right there. I mean, essentially this provides for the LAN product provides for a very flexible, very scalable solution, and now we incorporate our splitter into that solution. And of course, this splitter is available in any ratio from 1:8 up to 2:64, so it can support virtually any POL deployment. Of course, the common splitter ratios are shown there, and that's a little bit about the product. So now we're going to kind of look at how the system fits together, just really at a high level. So if you look at the bottom on maybe floor 1, the OLT there is connected into your core router and into the wide area network and the internet, of course. And then you're going to jumper from the OLT, which is the device shown here, and essentially that's going to go into the CCH housing through your standard riser cabling, whether it be a standard MIC type cable or maybe an interlocking cable, up to the individual floors. And there's really two approaches to deploying POL. There's the zone design and then the star design. So the zone design essentially uses telecommunication enclosures or zone boxes located in the drop ceiling environment. And essentially there you're just patching through the CCH housing or the WCH housing in the telecommunication room. You have a drop cable going out to the fiber zone box feeding the splitters, and then from there you have individual single fiber drops feeding to a wall outlet, and then a jumper feeding into the ONT where your end devices are connected. The top floor design there, which is the star design, is essentially just locating the splitters in the IDF. And so you could essentially imagine that the splitter is taking the place of the layer 2 switch that would be located in the IDF. And then from there you have a single fiber drop out to the wall outlet, of course another single fiber jumper into your ONT. So that's a traditional POL example. Now we're going to look at one that we're seeing used more and more. It's the idea of converging POL and essentially serving POL out of the telecommunication enclosure. So with POL convergence, I mean essentially you're taking the OLT shown here on the first floor, connecting that into the standard CCH housing. In this case we're showing a pigtail trunk. So in other words, we have a cable that has connectors already pre-installed on one end and the other end is left bare, so that it basically makes it easier to pull through congested pathways. Maybe you have a riser that already has a lot of cable in it. You can easily pull that cable through the pathway. And then we have an LC splice cassette here. One thing we should point out about the POL converged solution is that it takes advantage of LC APC connectors, because in our converged solution where we have a DAS, it's an LC-based system. Now, the OLT and ONT electronics use SC-type connectors, SC APC, but we can easily adapt that to the LC backbone by using just a hybrid jumper at the ends of the system. An LC to AP, an LC to SC APC jumper. So what's happening here is we're actually sending our fiber cable up through the riser space to the top floor here. And here we have a device called an ICU, which is a power delivery device. It's an interconnect unit. It delivers 100 watts of power out to the individual ONTs. And then from there we have end devices that can be connected into those ONTs. They can serve wireless access points, security cameras, really any IP connected device can be plugged into that ONT, because they do provide for up to PoE plus power. And then of course if you want to install an ONT at the desk level, at the user level, you can actually just run or interconnect a single fiber drop cable from that telecommunication enclosure and serve an individual ONT. So that's really a little bit about our vision of networks going forward and how we should essentially create networks that are simple, easy to administer, and basically advanced so that they're going to match up to the demands that are going to be put on the networks into the 20-year horizon. So that's really all I have. I think we're going to turn it back over to Carl for some questions.
Great. Thank you very much, Ray and Dave. This has been great. We do have some questions, so there's a couple of them already in. While we're going through the Q&A, remember that you can click the dialog box, Q&A button at the bottom of the screen, open up a dialog box, type your question in, and we'll get to it. It'll pop up on my end, and we'll review the question so everybody can hear it. Also, I wanted to let everybody know that the presentation is archived, and you can get it again later if you go up to graybar.com. The first question is we've used some alphabet soup in our presentation here, so let's, if we can drill back just a little bit, can you describe what an ONT is? I'm getting the vision in my brain that it kind of looks like an edge switch. It looks just like an edge switch. Is that true? What's an ONT and what's an OLT? Can you give us a brief description of that? Ray?
This is Dave. I'll take that.
Dave? Okay, Dave.
Yes.
Let me, I'm going to take us back to one of the slides, slide 14, and what it shows is in the lower right-hand corner, I'm trying to wait for it to come up here. Yeah, so it shows the bottom right-hand corner what the passive optical LAN looks like. And what you'll see is right in the center of that diagram is GPON OLT. And what that is, that's an optical line terminal, and that replaces the core Ethernet switching infrastructure that you would need to have in a building to build your local area network from. And in that core switching infrastructure, generally you run some single mode or multi-mode fiber up the riser to the closets, and then the closets would have more switches. Well, the GPON OLT actually uses a splitter like that Ray described, and at the edge, so that you can connect an Ethernet device to this optical network, is a little device. It's roughly the size of a paperback book, a little smaller in some cases, that has a number of Ethernet ports on it. You can get them with 4. We have some with 2, all the way up to some rack-mounted units that would have 24 ports. And that device is, while it's a device that requires the power, and it can provide PoE power to an IP phone or whatever, the way Tellabs designs those devices is that they are completely unmanaged on an individual basis. There's no configuration port on them. There's nothing you can do except plug an optical fiber in, and all those are managed from the OLT via the centralized console. So you don't think of them as remotely configurable devices, but they are very intelligent in that they allow you to assign bandwidth to those ports, manage that traffic and the flows that we talked about in a positive way, as opposed to just hoping the traffic goes through. So they're intelligent devices, but they don't hold any configuration information or any data that could be intruded upon. So it's just a small device at the end of the network that allows you to plug in your Ethernet-based connected devices like cameras, computers, phones, those kind of things.
The next question is just my own, just to add some little clarity to our conversation today. And we use words when we talk about POL. We use the word passive optical LAN, and sometimes our brains get upside down with this. Is passive good, and is complexity bad? And is a PON really just basically a straight line connection between the core router all the way to the edge? And here's where I'm getting at with this question. If I'm an IT person, am I going to lose control of my network? Am I going to lose features that I'm used to having in a network, like setting up VPNs and QoS and some of these other things that I need to do as a network administrator? I mean, do we still have that functionality even though we're using the word passive when we describe a passive optical LAN?
So that's a great question, Carl. And yes, you have that. I would, not to sound like a salesman on TV, but you have all that and more. So really, yes, the QoS settings that you would have defined in your core router, those QoS settings get passed transparently through the network. Simple doesn't mean less capable when you're talking about a passive optical LAN, because as you're connecting to that core network, what I now have is a defined network with defined paths that are reliable, secure, and configurable. So I can take a port on those ONT devices that we talked about that's connected to an IP phone, and knowing that IP phone never needs a gigabit port worth of speed, I can configure that IP phone to have a 1 meg of guaranteed connectivity, and it will never have less than that on the network. I could take a power user and guarantee that power user would never have less than 100 meg worth of bandwidth back to the core of the network. So allowing me to define the limits and the pathways that traffic is going to follow, compared to an Ethernet network where my really only solution to a bandwidth challenge is to throw more bandwidth at it. Gives you a much more flexible and configurable network that allows you to give the users what they need at the point they need it, and not have to just over-provision bandwidth and hope that everything works.
Thank you very much, Dave. I wanted to remind everybody on the webinar today, if you'll type these words into the Q&A box, more info. Just type in the word more info. One of us will call you back. It'll be either Dave, Ray, or myself. We'll get back in touch with you, and we'll arrange for a deeper dive. We can do another webinar, and we can really get into the nuts and bolts of how the network actually works, what's inside some of these boxes. If we're talking about an OLT or an ONT, we can talk about some of the dynamic things that can occur in the network. So if you'd like to take a deeper dive and you'd like to know more about how these networks are architected, and you would like to know a little bit more about how they're put together, if you'll just type the words more info into the dialog box there at the Q&A, we'll get back in touch with you. We have another question here that came up really early in the presentation, and I'll just read it to you. Given the incredible availability to hack the most advanced networks, does reducing access to the one platform really make sense? This question came in from Todd. I think it was maybe somebody else. Can somebody answer that question about hacking networks and advanced networks and reducing access to one platform? Does it make sense?
Sure. This is Dave. I'll answer, and then I'll let Ray talk a little bit about the security of the actual fiber infrastructure. One of the things about a passive optical LAN, from the ground up, it was designed to be secure. So where, again, Ethernet, because of its heritage and where it came from simply connecting devices together on a network, the security that's built into Ethernet really a lot of times isn't sufficient, as was pointed out in the question. And so what the inherent security that's built into GPON, as Ray mentioned, is the encryption that happens on the actual network. And the fact that you're putting all these devices onto one secure network as opposed to, connecting them to multiple networks that are all cabled individually and built individually, I think putting them on one secure network is less risky than putting them on multiple networks and hoping that only one of those multiple networks gets hacked and takes down one of your services. So I'm of the school of thought that if you really want to secure something, you build a secure platform for it and put your services on that secure platform and go about it with that approach, as opposed to the multiple network theory that says, well, if they only hack one of my networks, they won't hack the rest of them. And then I'll let Ray talk to the security of fiber itself.
Yeah, so just kind of along those lines, so the analogy is kind of like, would you put all your eggs in one basket, so to speak? So I think you would if that basket is made out of concrete with a lockable metal door on it or something. But I mean, essentially that's really what Dave was saying. The passive optical LAN was designed to be secure. The medium itself is really inherently secure. Optical fiber is difficult to tap. So if you do gain access to the fiber by basically destroying the cable to get access to it, you basically still have to get past the 128-bit encryption of the passive optical LAN or the GPON signal itself. So it's very difficult for someone to tap into that media. In addition to that, there are companies out there who make monitoring systems which essentially use non-data traffic fibers, or we call them maybe dead fibers, in the optical cable to monitor that cable. You can literally detect when someone touches the cable and moves the cable to try to gain access to it. So these systems are inherently secure. All the three-letter agencies of the federal government, if you look at how many of those folks have actually installed these POL systems, it really shows you that these are probably among the most secure networks that are available today.
If a network is very critical to a person's mission or objective from a business perspective, we know that one cut in one fiber line could kill a large portion of the network here. Is there abilities to build a redundant path in here so that if one fiber would be disrupted or something would change, we could fall over to a redundant path and keep the network from going down. Is there a way to build redundancy in these networks?
I can start out with that one, and then I'm sure Dave will have something to say on this one as well. But
Sure.
From Corning's perspective, as far as the passives go, we make 2x splitters that basically allow you to have a diverse pathway to the optical splitter, and so you absolutely can incorporate redundant pathways, and you can basically run those back to multiple OLT devices to gain that redundancy within your system. And Dave can speak on the electronic side of it as well.
Right. So as Ray said, the multiple OLT solution is employed by a lot of people who are concerned about the ability for a fiber cut to take down a network. And so part of the Tellabs OLT solution is the ability to have two OLTs connected, or have your ONTs out at the edge connected back to two OLTs that are in disparate locations. So they're not located next to each other in the same rack in the same building. You've got a 20-kilometer distance you can have between those devices, and that whole ability to separate the OLTs gives you a lot of reliability. And so on the cable cut side, you've got reliability that you can put in from having two separate OLTs at the core. But also the grade of components that are used in these are carrier grade components, so that the risk of fiber cuts can happen, and there are ways to mitigate those with the conduits and the placement of the cables. We also have more reliable, quite frankly, electronics that allow you to get up to 6 nines availability. So with an optical LAN solution, you can get at a reasonable cost 6 nines availability, which is less than 30 seconds of downtime in a calendar year. So yeah, the reliability of these networks are definitely part of the consideration, and we have several different ways to go about making sure they're reliable and resilient.
Again, I wanted to remind everybody, if you'd like to take a deeper dive, just type the word more info in the Q&A box, and one of us, either Dave or Ray or myself, will call you back, and we'll make arrangements to do that for you in another webinar. Might be a way to do it. A question came in from Jeremy, and here's what Jeremy asked. If there's no configuration at the end, and I'm assuming the end of the network there, how do you handle multiple VLAN requirements in the same physical area? How does that work?
And that is a good question, and I appreciate Jeremy asking that question. So those end devices, those ONTs that sit at the end of the network, while they don't store configuration, they are highly intelligent and configurable. We can carry multiple VLANs. You can have different VLANs on every port that's on that end device. So if you have a 4-port ONT device at the edge, you could put a VLAN 1 on port 1 and VLAN 203 on port 2, or you can carry multiple VLANs through a given port. So yeah, we support VLAN configurations in several different ways. For those of you who use your IP phone to connect to the switch, and then a port on the back of the IP phone to connect your computer, we can carry both those VLANs back transparently through the network. That is not an issue at all. So those devices, while they are not individually configurable at the location, we secure them that way so that they're not. When you boot that device up, when you plug it in, it goes back to the OLT to find out what its VLAN configuration is, what its security requirements are, whether or not it has to have 802.1x security to force authentication before getting on the IP network. So yes, there are all of those options that are in a traditional Ethernet network that would be required are fully supported in the passive optical LAN scenario.
Well, we're running out of time, and I think that'll have to be our last question. As I'm closing up here, if you have another question, be sure to type it in the dialog box, and we'll get back to you via email. If you'd like some more information about passive optical LANs, type the word more info in the dialog box, and Dave or Ray or myself or maybe all three of us will call you back. Remember, all of us will be at Bixby at booth number 1331 is the Apple LAN booth, and you can get more information there about this, or you can see any one of us at our individual booths at Bixby, whether it be Tellabs, Corning, or Graybar. I wanted to remind everybody that this presentation, as you saw it today, those slides will be up in our archive in a PDF format. So all the presentation slides that you saw, you'll be able to see those. You can also get the audio. You can get that, and you can share this. There'll be a URL there that you just have to click on or share with someone else, and we're glad to pass this and cascade it along to those that are interested in this information. If you're one of the 50 people that hung in there, and you'll get an email for a free cup of coffee, and we're just glad that we were able to offer that to you today. This was a wonderful presentation. We see how networks are changing. Advanced networks is part of what Graybar wants to help provide our customers with more information and more knowledge about. We'd be glad to help you and answer any questions you have about any kind of advanced networks, and this is one that's really, I think, going to take off here. So anyway, thank you very much for your time. You have a great day. Thank you, Ray, and thank you, Dave. This has been an awesome presentation, and we'll see you next month for another G2 Talk webinar. Thanks again. Have a great day.
Thank you.